An inverse trig derivative, I don't even know how we would do that, but we want to find the derivative of this. And since I don't know how to do that, what I'm going to do instead is I'm going to write it as a variable y, like this. And now my goal becomes to find dy dx, right? That's the same as what we were saying this whole time already. And another thing that I know is that I can write it as x equals sine of y, because they're inverse functions of each other. This is an equivalent statement. And with this equivalent statement, we can take the derivative like this. And the derivative of x is 1. And the derivative of sine is cosine, you know that. But don't forget from the chain rule, when you do a function, it's derivative of the inside or the outside times the derivative of the inside. I hope you remember that. So we have to have a dy dx out here. And my whole goal is to find dy dx, because if I can find the derivative of y, then I've found the derivative of arcsine. Now I created this y so that I don't have to write arcsine. And that means we're going to need to eventually remove it. But for now, we can say dy dx equals 1 over cosine of y. That may not seem very helpful at the moment, but let's just remember something here. I'll put it on the side. Sine squared of anything plus cosine squared of that same thing is equal to 1. So if I want to replace cosine of y, you got to move this over and take a square root, and you're going to end up with dy dx equals 1 over the square root of 1 minus sine squared y. That doesn't seem to help much, does it? But look at this. We know what sine of y is, and it's right here as well. It's just in squared form. So I can say dy dx is equal to 1 over the square root of 1 minus x squared. And wouldn't you know it, that's the derivative of arcsine right here. You found it, just like that. That's the derivative right there.